why you should study learning technologies. If you think you can make education better, join us in exploring ways to add things like cell phones, tablets, computers, virtual reality, and other emerging tools to make education even better. Hello, my name is Dr. Aleshia Hayes, and I am an assistant professor of learning technology in the College of Information at the University of North Texas. My research focuses on emerging technology tools that we use for learning and how to make them as effective as possible. Specifically, I really focus on simulations, games, extended reality, things like virtual reality, augmented reality, mixed reality, and that's why my lab is called SURGE, which is the Simulation User Research Game Experience Lab. And what we do in SURGE Lab is look at ways that we can make learning technology more effective and look at ways that we can design new effective learning technology with emerging tools. So one part of my research area that I love is looking at what is working well in games and figuring out ways to transfer what elements of games are very effective to learning. This is what we call gamification. Similarly, with extended reality, we look at levels of immersion. So we have things like 360 video, where you can look around on a flat screen and see around, or if you've played video games like World of Warcraft or any kind of immersive game, you can kind of look at things in a 360-degree way versus looking at something in a VR headset that you put on your face, and then what level of immersion you get from that. Similarly, with extended reality, we look at levels of immersion and how something like VR may be more engaging than something like a YouTube video. We think about the costs of these tools versus how beneficial they may be to learners. The fun part of this kind of research is that we get to explore what it means for learning technology to be effective. So obviously, learning technology is effective if people learn more. But there are other ways that technology can be effective. For instance, if a learning technology is fun or engaging to learners, then that makes it effective. Also, if people remember what they learn more in a certain environment than they do, say, from reading it in a book, then that makes it more effective. So you can imagine, for instance, having an experience of going to Mount Rushmore versus seeing a picture of Mount Rushmore in a book. You probably would remember the experience more than you would looking at it in a book. So one of the things also that's fun about my research is it's very interdisciplinary, because creating simulations, games, and virtual experience often takes work from multiple disciplines. So one project that my lab created that was very multidisciplinary was a troop movement virtual simulator for the ROTC. So this was for ROTC students to practice telling troops what kinds of positions to move in. We worked with military experts and also included students with graphic design expertise to create the environment, and other students from computer science to code the experience and integrate the immersive hardware. We also worked with psychology students to do the user testing and actually run participants through the experience once it was created. And in addition to the traditional VR equipment, we also integrated emerging tools such as the Leap Motion that can track users' hands while they're in virtual reality, and we used a VR treadmill that allowed users to walk freely through the virtual environment. So instead of just using a controller to move around, they could actually walk around with a VR headset on and this treadmill and navigate through the space. So with user research, part of the job is observing what people do, so we watch what they do. And the other part is asking them to tell you what their experience was. And some of these ways we use are through surveys. Sometimes we actually just ask questions. Other times we do more kind of scientific, slightly invasive things like using EEG or EKG to look at their brain responses, brain activity, heart rate changes. We look at things like galvanic skin response, so we can see if someone is say, for instance, more engaged or nervous, they tend to have just slightly more conductive skin because of the sweat in their skin. We also can do things like track behaviors that people have. So for instance, we can look at where people are looking on a screen to see what objects are engaging them. So with the ROTC simulator, we watched users in the experience, and we saw that they did learn gestures for troop movement in a short time. And we also asked the users to rate their sense of how easy it was to use the experience, and if they were tired from the experience, and what was confusing and frustrating. One of the things we did find was that the VR treadmill that we used was not super comfortable for users, and that's just kind of a development thing that we need to work on, engineering better VR treadmills. And the other thing that we did notice was that when we used the hand tracking, we actually had people put their hands up to do the gestures for troop movement control, and we found that the leap motion was effective in capturing their gestures, which we were very happy about, but it didn't actually have the range that we needed, because normally people would do a troop movement gesture off to the side, and for them in the simulation they had to do it right in front of their face, which is not optimal, because we definitely don't want to train people to do something in a way that's not natural in the real world. So we can use all of these things to iterate on this simulation and make it better for next time. Another study we have in conjunction with colleagues at other universities is on an immersive piece called Greenland Melting. We're looking at the learning and emotional impact of experiencing a short film about global warming and Greenland melting in a 360 video displayed on a monitor versus looking at that same video in a VR headset, which allows the user to look around intuitively and naturally. So looking at it on a monitor, where you have to kind of scroll to look around, versus looking at it in a VR headset, where you get to naturally and intuitively just look around and see what's above, beneath you, behind you, that kind of thing. So far, we found that people remember facts from the flat screen video more than they remember facts from the 360 video presented in VR. However, they report feeling more connected with the material and caring about the material more when they were in the VR experience. Future research on this, of course, will look at whether people remember the experience more in either environment, and also really get into other levels of learning. So is it just that we want people to remember facts, or do we want people to remember facts and also have the sense of caring and empathy about things, which we know we can get with virtual experiences? So in my work, I work with undergraduate and graduate students to support multiple levels of research. Generally, computer science and learning technology students work with me on designing learning experiences. Frequently, we have the support of a subject matter expert in the subject we're teaching. Once the learning experiences are designed using methods such as storyboarding, we move on to the development of the experiences. Currently, much of our development work is done in either Unreal or Unity. I also work with students in the field of psychology to help us run our user research studies. And finally, all students I work with are encouraged to contribute to the papers we write about present posters, or talk at local conferences or even international conferences. So there's a great deal of opportunity, especially here at UNT, for even undergraduate students to collaborate with faculty like myself and also graduate students. If you're interested in working with me on my work or working with someone else on similar work, I recommend visiting labs and finding out what faculty are working on, what labs are doing. If you're interested in development work, I highly recommend spending some time getting familiar with either Unity or Unreal or both. If you're interested in design work, I recommend practicing storyboarding. And of course, everyone I recommend practicing presentations and the thing that people frequently don't like. Group work is actually super important, and being able to do these collaborative research projects. Time management is very important. So practicing these things in your classes as you're going along right now is going to be very beneficial for you. While some of this may sound unmanageable, remember, in addition to your coursework, there are tutorials online. Unreal and Unity have many, many tutorials available. There are frequent sessions held at our UNT libraries for these skills as well. Likewise, I recommend getting connected with student groups and like-minded individuals to work on projects. And we have so many groups here at UNT. I've enjoyed working with our game dev group, but there are many other groups that are available. And if there's something that you're interested in exploring and you haven't found a group for it, maybe you can find the time to create one yourself. Thank you so much. I wish you the best, and I hope that I get to work with you as a research assistant or a colleague one day in the future. Thank you.